Hello. I'm going to explain how we solve this today in class. I'm not going to be showing myself this time. I hope that's okay. I look pretty busted, so I'm just going to do the screen recording like this. Alright, basically we had, the slides to refer to. I used that a lot. Hopefully these are right. But yeah, okay. Suppose a new immunodeficiency virus called NAUIV is discovered and is spreading rapidly across the world. Fortunately, is similar enough to HIV that the current drugs used to treat HIV are effective against it, but the parameters concerning its genome size and mutation rate are different. So this is just all the information we're given to help us solve these, and we're given this table to fill, which I just took a picture of and put it in here. These are all the values I solved for. The first row that we're solving for is the probability. And to find the probability, we go ahead and use this wait, give me a second. We go ahead and use this equation we're given. I'm pretty sure it was in the slides. A lot of it was in the slides, and a lot of it I had to refer to for the slides before I did AI. Yeah, so it was in the slides. Me and my group, everyone around us sort of just used that and plugged it in. So yeah, that's kind of how we did that. All this and this. 0.2 is the mutations per replication cycle, which was given, but also with the numbers that were given too that we would have multiplied. We just didn't because it was already given to us. We go ahead and use that. We go ahead and use that here. There's just a lot going on. Like, I did it all and I understand it, but there's just so many, like, especially when we get to down here, there's just a lot going on for me to be able to explain it specifically. But yeah, we kind of just plug it in, we get our numbers, and then I don't think we really needed it as percents because, for example, even on the back of the paper, they're not presented as percents, but still, I don't know, I guess I'm just used to it. So we have all of our numbers, how we calculated there. I'm also trying to make this video shorter because my past ones just feel like they're too long. And then our next row is the number of mutations created per day. With this, we take our numbers that we just calculated and we're multiplying it by 10 to the 8, which, hold on. That's supposed to be 10 to the 8, I'm pretty sure. Yeah. Which we're given, and since we're finding per day, we're just going to go ahead and use the factor that we're given, or the number that we're given. And we're just multiplying that. We get big numbers, but if we show it in scientific notation, it's a lot better. And then the third row is the number of possible mutants or mutations, which we're given a formula. Sorry, I'm scrolling over here on my laptop. Yeah, so we have our formula. Let's see, I did write it over here. Give me one. Okay, so we're given a formula. I think this is the simplified version, but this is exactly what we have to use right here. This is per base changes, so we have 0, 1, 2, and 3, of course, like all the other ones we did earlier. I is the number of mutations, and then N is the number of bases in the genome, and we're given that number, which goes to 50,000. The one in the example that we looked at in lecture today was 10,000, but ours is 50,000, so it's definitely different from the math on that one, but it's kind of all the same. It's 3's in the formula, so we're multiplying 3 whatever to each of these. Yeah, you just kind of plug it in. You have 50,000. Simplifying it, putting it in the calculator. Wait. I think, okay, so our group decided that like these factorials would be able to cancel out and make it a lot easier. But, oh yeah, simplifying it while doing it on the calculator instead of putting it in as we see here, like exactly like these, we just go ahead and like subtract 1 from 50,000 or 2 from 50,000, you know. I definitely did not put it in like this, but yeah, after calculating all of those, we get these numbers here. And then to find the fraction, that is also given in the slides, which is just the number of mutations per day divided by the possible mutations. And yeah, I just did that down here. Yeah. That's about it. Hopefully that's okay. I don't want to speak too much, but yup.